Let's solve few problems based on the concept whatever we have learned. Look at the first one. In each of the following cases, state whether the function is one-to-one, onto, or bijective and justify your answer. See, when we have to justify the answer, basically you need to prove it is either one-to-one or onto or bijective, whatever it is. Fair enough? Let's start with the first one. See here, the first one, function f is from R to R. That means set of real number to set of real number. Domain is a set of real number. Range is also a set of real number. So what we have is that f is from R to R. Domain to range, real number to real number. And also f of x is defined by 3 minus 4x. Now, first we'll do for one-to-one. Alright, so first we'll do for one-to-one. See, when you're doing for one-to-one, what do we have in one-to-one? If f of x1 is equal to f of x2, and if x1 is equal to x2, then we say that it is a one-to-one, or you can call it as an injective function, isn't it? So what we have, f of x1 is equal to f of x2, and this implies x1 should be equal to x2, isn't it? So in this case, what we get, 3 minus 4x1 is equal to 3 minus 4x2. 3 and 3 cancels, isn't it? Then minus 4 cancels. So what do you get? x1 is equal to x2. So this proves that the function is one-to-one, isn't it? Because we proved, see, we know that f of x1 is equal to f of x2. And from that, if you get x1 is equal to x2, then of course it has to be one-to-one, isn't it? Now the next part is onto, or you can call it as surjective. Onto. What does onto tells you? It tells us that for every image in the range, there has to be a pre-image in the domain. Correct? In layman terms, no element in the set of range should be left out. There has to be at least one connection to every element in the range. Isn't it? In layman terms, this is what it is. And we are looking at that particular part now. That means we have a range that is nothing but y value, or you can call it as f of x, because y is equal to f of x. So for onto, what do we say, or what do we do in this case? We have y is equal to f of x, correct? So we have y is equal to 3 minus 4x. Now, what we are trying to show, or what we are trying to say here, for every value of y, we have a value of x. And I am not talking about a unique value, just a value for x. So that's all. All right. So what we'll do, we'll make x as the subject of formula. All right. So you get 4x is equal to 3 minus y, transposing x is equal to 3 minus y divided by 4. Now you know that x and y are real numbers, isn't it? So what can we say? For all y belonging to R set of real numbers, x will also belong to R, correct? That means no matter what the value of y you have, there will always be a value of x corresponding to it, isn't it? No matter what the value. That means every element in the set, the range set, or you can say every element of y has one pre-image in the domain set, correct? So what we get here, for all y belongs to R, comma x also belongs to R. That means what you can say, that f is onto. And here we prove that f is one-to-one. F is one-to-one and f is onto. So if it is both one-to-one and onto, then what type of function it is? It's a bijective function. So the first one here is a bijective function. Fair enough? This is how you prove it. Now let's do the second part in the same thing. See the second one? Again, you have a function f from set of real numbers to set of real numbers r to r, and the function is defined by f of x is equal to 1 plus x square. Right? Now we'll do for 1 to 1. See, when we are doing for 1 to 1, again f of x1 is equal to f of x2, and this implies x1 is equal to x2, right? So the first one, 1 plus x1 square, 1 plus x2 square, 1 and 1 cancels. So what do you get? X1 square is equal to x2 square. When you take the root, we get plus or minus, isn't it? So what do you have here? X1 is equal to plus or minus x2. So can you say that it is 1 to 1? Absolutely not, because we have two values. So what we can say, f is not 1 to 1. F is not 1 to 1. Clear? Now let's do the next one, that is the onto part. Now for the onto part, what do we have? We have y is equal to f of x. So y is equal to 1 plus x square, correct? So we have, correct? So we have x square is equal to y minus 1. Sorry, x square is equal to y minus 1. And now x is equal to plus or minus root of y minus 1. Now see, think about it. Y is a set of real number, isn't it? All real numbers I can choose. What if I choose a value of y which is less than 1? For example, say I take my value of y as half. Half minus 1 is negative 1. And root of negative 1 by 2. Half minus 1 is minus half. Root of minus half is going to give me a complex number. But here my function is from set of real number to real number. There is no complex number involved. Correct? So what can we say here? We can say that for all y less than 1, and negative also you can take, but any value less than 1. Negative is possible, yes. So to be more specific, you can say you can include 0 also. If y value is between 0 to 1, or any negative number actually speaking, alright, any negative number, x does not belong to R. Make sense? So what can we say? F is not onto. So F is not 1 to 1, F is not onto. So these are the answers for the first two questions. Now we'll go for the next one. The second one, let A is equal to R minus 3 and B is equal to R minus 1. That means set of real numbers except 3 and set of real numbers except 1. Consider the function f from a to b defined by f of x is equal to x minus 2 by x minus 3. Is f 1 to 1 and on 2? Justify your answer. See, when you have to justify the answer, you have to basically prove it. Prove that f is 1 to 1 or show whether it is possible or not. Basically, you're doing that. Clear? First, we'll start with the given function, the given condition, then we'll start with 1 to 1. See here, the given function f(x) is x minus 2 by x minus 3. Remember, the function is from r minus 3 to r minus 1. You know why we wrote it this way? Because look at what is there in the question. F is from a to b, and a is nothing but this, isn't it? And b is nothing but here, a to b. B is the range, a is the domain, and b is given by this. Now that we have a particular domain and range and the numbers, the values, what it can take, we can write it this way. I mean, both are one in the same, isn't it? Okay, now first we'll start with 1 to 1. Now when we have 1 to 1, f of x1 is equal to f of x2 and x1 is equal to x2. We need to prove it, isn't it? So in this case, we can have x1 minus 2 by x1 minus 3, x2 minus 3, isn't it? So this is what we have. Guys, remember, we need to show that x1 is equal to x2, isn't it? Cross multiply. Best thing to do is cross multiply. So when you cross multiply, you get x1 minus 2 into x2 minus 3 is equal to x1 minus 3 into x2 minus 2. What we have? Multiply x1 x2 minus 3x1 minus 2x2 plus 6 is equal to x1 x2, oh sorry, minus 2x1 minus 3x2 plus 6. See the values, plus 6 cancels, x1 x2 x1 x2 cancels, right? So what do we end up with? We end up with minus 3x1 minus 2x2 is equal to minus 2x1 minus 3x2. Now what we do? We take the negative sign common. And you can take the x1 also, I would say. So in this case, what do we do? See here, take the 3x1 this side, take the 3x2 this side. Okay. So when you do that, 3x2 minus this one, so you get x2, 3x1 minus the 2x1, x1. So what do you end up with? x2 is equal to x1, and this is what we are trying to show, 1 to 1, isn't it? So my function f is 1 to 1, and we justified the answer. Now we'll do the same thing for onto, right? For onto now, onto is what? You have y is equal to f of x, correct? So we have y is equal to x minus 2 divided by x minus 3. Remember, we are trying to make x as the subjective formula. Cross multiply xy minus 3y is equal to x minus 2. So take the basically take the x value and y value. We need to separate both of them. Okay. So you can write xy minus x is equal to 3y minus 2. Correct. So x into y minus 1 is equal to 3y minus 2. 2 divided by y minus 1. Now, this is the reason why they have given in the range b is equal to r minus 1, because r, of course, y value cannot take a value of 1. Now, what do you need to prove? You need to prove that this, whatever function we have, it will all have an image in the set of range. This is what we are looking at, correct? Now, here, what we know is that they're all set of real numbers. All of them are set of real numbers, isn't it? So, for all y belonging to r minus 1, because you know that y value cannot take a value of 1. For all y belonging to r minus 1, there is or there exists, that also you can write, x belonging to r minus 3. Any value you take, this is what we have. So that means f is both 1 to 1 and but f is onto. Therefore, f is onto. Got it? That means it's bijective. So what we have done is first is we took the 1 to 1 part. Again, you equated, you will get it. Next, for the onto, this is what you do. Clear? So this is the answer for the second question. Now we'll do the next one. Let A and B be sets. Show that f from A cross B to B cross A such that f of A comma B is equal to B comma A is a bijective function. Very, very easy question. Now what we have is we have function f from A cross B to B cross A. Basically what we have, A comma B belongs to A cross B and B comma A belongs to B cross A. Isn't it? Because f is from A cross B to B cross A such that f of A comma B, see this is given to you. That's how we get to know that what belongs to what. Now we'll do for 1 to 1. We'll go for 1 to 1. Now for 1 to 1, f of x1 is equal to f of x2. Then you can see that x1 is equal to x2. This is what we are trying to prove, isn't it? So when you say f of x1, I cannot have one element. I need to have two elements, isn't it? So instead of f of x1, we can say f of x1 comma x2, two elements. So when you have f of x1, or I can take it as f of x1 comma y1, I think that will also work rather than taking x1 comma x2 because that might cause some confusion. Let's call it as x1 y1 x2 y2. Okay, I mean it makes more sense also. So what we have now first is f of x1 comma y1, right? So this is equal to y1 comma x1 because f of a comma b is nothing but b comma a. So this is what we have. Likewise, x2 comma y2, y2 comma x2. Right? So now what we have, y1 comma x1 is equal to y2 comma x2. Now remember, it's an ordered pair, isn't it? See, what you have in an ordered pair, that particular values you have to match, or in other words, the particular values are equal, correct? So since this is an ordered pair, we can say that y1 is equal to y2 and x1 is equal to x2, isn't it? So y1 gets compared with this one and x1 gets compared with this one. So what do we get here? We are going to get 1 to 1 because both x1 is equal to x2 and y1 is equal to y2. Both are satisfied, isn't it? So the function f is 1 to 1. Now we have to look into onto part, okay? See, onto is what we get, that for all b comma a, there has to be a comma b, correct? Now again, we'll take the function f from a cross b to b cross a. Now, for all b comma a belonging to b cross a, should exist a comma b which belongs to a cross b, right? Okay, now since we are looking into this particular scenario, see b comma a belongs to the set b cross a, correct? B cross a. Now a cross b to b cross a. So what we have is f of a comma b is equal to b comma a. General term, what we can tell and what we can confirm is that for every b cross a or for every b comma a, there will be one image or one pre-image in the domain. That means what we can tell is, since b comma a belongs to b cross a, comma, there will be a comma b which belongs to a cross b. That means f is onto. Since it is both one-to-one and onto, what can we conclude at the end? We can say that f is a bijective function. F is a bijective function. So we just proved that y is a bijective function. Alright, so in the next video, we'll discuss about few other topics.